being recorded.
Thank you.
You're welcome.
Post your question using the hashtag #UnfoldTheUniverse, and we'll be taking some of those along the way as well. We're going to start out with Thomas Zurbuchen, the Associate
Bueno, Thomas Zurbuchen es el primero. Arrancamos de una
in
con
Washington,
esto.
D.C. Welcome.
I'm so glad to be here. What a day, Karen.
It's exciting. Tell us why we're here.
Well, look, this is one of the most magnificent
Todos saben que Thomas Zurbuchen es administrador
sitting there
asociado.
right now, and each and every one of them is so important, from different organizations, from Goddard Space Telescope, Northrop Grumman, Ball.
Van a ver el audio desviado, o sea, no está en fase con lo que estamos hablando, lo que están diciendo, justamente porque las imágenes son de internet, pero el audio es directo, estamos conectados vía teléfono.
From the idea stage 20 plus years ago with 10 plus new technologies that had to be invented, coming up with this fragmented mirror, 21 feet across.
Bueno, han alineado todos los espejos.
Not conceived before, and now putting it together to get to this place, of course, launching from Kourou together with our international partners, deploying it seamlessly in space, and now aligning that optics.
Great. I've heard you talk a lot about this team and your admiration for this team. And my understanding is this is really the first time we've ever done this, where we've had to fold.
Es la primera vez que hacemos esto, le está diciendo la chica que está hablando, que es quien está moderando.
Talk me through that a little bit. What
Bueno, le dice, yo sé que está muy orgulloso de la gente, porque él habló mucho de la gente que estaba rodeada.
Look, I mean, when we have a mission normally elsewhere in our portfolio, we think of like one or two, I call them miracles, you know, kind of new ideas, entirely new technologies that when we start, we don't know yet whether they're going to work. This telescope, this observatory now had 10 of them, perhaps even 12, depending on how you count. And you should know that the ingenuity of the entire team, you know, the diverse team that came together, the best that they offer from the international community, got us here. You know, for me, when I think about this, frankly, I've said it before, I'm saying it again, I think of that amazing challenge, really at the edge of what's possible. And they did it in a way that, frankly, to outside observers, make it look easy.
Bueno, para la gente que recién se suma y se está sumando, estoy acreditado en esta conferencia de prensa de la NASA respecto al alineamiento exitoso de los 18 espejos principales del James Webb con la primera imagen, que en realidad es la imagen de alineación. La acaban de colocar en la web de la NASA, esa imagen está disponible. Y bueno, para eso están en esta teleconferencia Thomas Zurbuchen, que es quien está ahora en pantalla, que es el administrador asociado del Directorado de Misiones de Ciencia de la NASA. Está también Lev Finbeck, que es administrador del elemento telescópico de James Webb, Marshall Perrin, que es el científico delegado del telescopio, Jane Rigby, que es el científico de operaciones, y Erin Wolf, que es la administradora del programa de vamos a tener oportunidad de hacerle quizás una pregunta, porque justamente nuestra acreditación nos permite que nos den lugar o no. Bueno, depende de qué tan rápido lo preguntemos o no, pero si hay preguntas respecto al tema, lo colocan en el chat, le ponen en mayúscula pregunta, que está permitido ponerlo, y ponen la pregunta al lado. Si lo ponen en inglés, bárbaro, mejor, si no, no hay problema. Bueno, quien va a aparecer ahora después de esta imagen es Marshall Perrin. Ella es científica delegada del telescopio en el Instituto de Ciencia del Telescopio Espacial en Baltimore.
Thank you, Karen. Well, we have now finished the fourth and fifth phases of the telescope alignment. We call those phases coarse phasing and fine phasing. And that's where we've made the primary mirror, all 18 mirror segments, into a single primary mirror. And we've initially aligned the telescope to the NIRCam instrument. That's the instrument that we use to do the alignment. And we've taken our first images. In fact, the team gathered over the weekend when the first images came down. We were in the Mission Control Center, and it was a very emotional moment. We kind of blew some of the image of stars up, and really could see how it was performing. And I'm happy to say that the optical performance of the telescope is absolutely phenomenal. It is really working extremely well.
Bueno, lo importante que está diciendo Lee Feinberg es que realmente todo lo que tiene que ver con el telescopio está funcionando tal cual ellos habían esperado. O sea, está funcionando bien.
Taken at roughly 2 microns, which is the wavelength which Webb was designed to work at or above. And you not only see the star and the spikes from the diffraction of the star, but you see other stars in the field that are tightly focused, just like we expect.
Dice, no solo pudimos ver ahora en esta primera imagen de alineación la estrella a la cual le apuntábamos, sino que también pudimos ver otras imágenes perfectamente en foco. Esta es la primera imagen del telescopio James Webb. Esta es la imagen de alineación.
And to give you some perspective of what has happened and sort of how the telescope got here, we want to run this video clip to kind of show you what the telescope has been through to get to this point.
Van a mostrar un video también respecto al tema.
Webb's science objectives required a large primary mirror, a mirror too large to fit inside the largest rocket fairing that exists. So we had to design Webb's optics to be folded. This meant Webb's mirror segments had to be extremely lightweight and individually controllable.
Bueno, está explicando un poco la construcción del James Webb, que en realidad que para poder colocar un espejo tan grande tuvieron que partirlo en pedazos y hacerlo extremadamente liviano, y esa es la parte más compleja del telescopio.
5 years ago was actually the last time we tested the telescope or took images with the NIRCam instrument, which is used to align the mirrors. At Northrop Grumman in Los Angeles, Webb's optical segment was integrated with the spacecraft and sunshield segment, and we did more testing. One thing we can't directly test on Earth is the effect of zero-G on the system. We use computer models.
No pudimos testearlo, dice, en la Tierra, dice, en un ambiente de cero gravedad, pero para eso usamos modelos computacionales. Bueno, esto es parte del embalaje y luego está hablando de la llevada a la Guayana, puesto encima del cohete el Ariane y el despegue, ¿no? Rosa Sierra dice, a ver las novedades del James Webb, se supone que todos los sistemas van bien, lo acaban de confirmar. Está todo funcionando perfectamente tal cual como esperaban. Adrián Braga, esa pregunta es lo estándar, lo que se espera, ¿no? Está muy buena la pregunta, pero es lo que se espera. Dentro de poco van a poder trabajar con él. Y esto es un adelanto justamente de lo que se viene.
One of Webb's final deployments was releasing the mirror segments from their launch locks. Then we could start the mirror alignment process.
Me sigo maravillando con esta imagen de la soltada del telescopio luego del despegue en el Ariane 5. Dice, este éxito en todo esto, dice, no ha sido por accidente. Desde hace 20 años que venimos trabajando con todo este equipo increíble de Northrop Grumman y otras compañías, dice, y otros colaboradores, y bueno, la Agencia Espacial Europea. Y toda la dedicación que le hemos puesto y todo el mundo le ha puesto a esto, justamente hace de que estos alineamientos, la performance de óptica, y estamos muy cerca del punto en que esto puede llegar a transformarse en un instrumento increíble de ciencias.
But we've sort of pioneered a new way to build large space telescopes, which we can give to the next generation and future generations.
Thank you so much, Lee. We are now moving on to Erin Wolf.
Bueno, Erin Wolf es quien va a hablar ahora.
At Ball Aerospace. She's going to give us some details about the engineering that made all this alignment happen.
Es administradora del programa web de Ball Aerospace en Broomfield, Colorado.
Technology development. The optical hardware
that we spent years manufacturing and polishing and measuring down to the tens of nanometers is working.
Bueno, dice la tecnología que hemos podido desarrollar con esto, dice, ha sido increíble.
The algorithms and the mathematical processes that we would need to perform this alignment in space. You know, we've never had a segmented telescope in space before, so we had to invent a whole new process.
Dice, nunca hemos tenido un telescopio de este tipo en el espacio, dice, hemos tenido que inventar absolutamente todo.
That dictates what our mirror moves will be on the motors. And it's actually been easier in space than it was in the lab.
El video está desfasado con el audio, exactamente, porque el video, sí, eso me pregunta Mirko Corso, lo dije al principio, justamente porque estamos vía telefónica con NASA en la conferencia y el video es lo que hay en YouTube, entonces hay un desfasaje. Podemos ponerlo, lo que pasa es que primero va a salir doble y después, si tenemos la oportunidad de preguntar, nuestra pregunta va a salir otra vez más tarde.
And it looks wonderful. So we're really excited. So far the process is working and the hardware is performing better than requirements. We couldn't be happier. And it's just a testament, like Thomas and Lee have said, to all of the years and years of hard work that everyone has put in. People that aren't necessarily on the team now for the commissioning, but they did the technology development decades ago.
La gente que ha trabajado en esto no necesariamente ha estado ahora en esta etapa. Esta es la etapa de lo que muchos le llaman el commissioning, que es la puesta en servicio. Quienes están trabajando en esto ahora quizás no son los que han trabajado en el desarrollo, en el armado, en el lanzamiento. Pero es increíble. Quien va a hablar ahora es Marshall Perrin, que es el científico delegado del telescopio del Instituto de Ciencia y Tecnología Espacial de Baltimore.
Got the mirrors out to about within a millimeter or so of their desired locations. But in order to have the mirrors all act as one, they need to be lined up to just...
Para poder hacer que todos los espejos del telescopio funcionen como uno solo, dice, justamente hay que alinearlos con una precisión increíble, ¿no?
We stepped through a long process. The team has been preparing and practicing for many, many years.
Bueno, y este proceso lo hemos practicado por muchos años.
That one from each of the mirrors. And we gather those together. We begin by aligning them all as if they were separate telescopes. We have 18 telescopes basically at this point.
Y hemos comenzado a alinearlos como si fueran 18 telescopios separados.
And bring them to the point that each of these 18 telescopes are sharp on their own.
Bueno, y hemos hecho que primero cada uno de estos telescopios, de estos 18 telescopios, produzcan una imagen perfecta. Esta es la primera imagen que se había logrado con los 18 espejos, ¿no? Nos marcan cuáles son las salas. Entonces miden, corrigen.
In order to measure the secondary mirror alignment between the center and the corners of the field of view. We use a prism to split the light from pairs of segments and measure the
usamos un prisma para poder colocar las imágenes de cada espejo.
And at the end of the process we use a set of defocused images that we take using lenses we put in the beam. It's sort of like being at the eye doctor and you test different lenses and see how.
Bueno, y lo que hacemos después es, en la etapa final, es desenfocar colocándole lentes delante, tal cual como hace un oculista.
To measure the mirror positions with the precision of just nanometers.
Y luego hemos determinado la posición de los espejos con una precisión de nanómetros. Nano es 9 ceros después del metro. Es 10 a la menos 9 matemáticamente. O 12. 9 ceros.
Did we have any significant technical issues with the telescope? Everything's performing at or above the expectations, as was said. There were a couple places with some surprises in the data, but little surprises. The biggest one, honestly, has been just how closely it matched the models and the predictions.
Bueno, dice, hemos tenido muchas sorpresas a medida que hemos hecho esto. Quizás la mayor sorpresa que hemos tenido es qué cerca que han estado los modelos matemáticos que hemos calculado a lo que hemos encontrado ahora en el proceso de alineamiento.
And as we were focusing the telescope, we were using typically one bright star at a time, a handful of different stars we used on the sky. But as we were focusing on those bright stars, we couldn't help but see the rest of the universe coming into focus behind them, to see the more distant stars and galaxies coming into view. And honestly, the team was giddy at times just seeing this happen. There's no way to look at these data and not be excited at the scientific possibilities that are opening up here. We've done this over the last several months within almost exactly on schedule. There's a few things that took a little bit longer than we thought. There are some steps that went faster than we thought, and so overall, we're really within just a few
Venimos completamente en fecha de acuerdo al calendario que nos habíamos fijado. Hay algunas cosas que se han adelantado, otras que se han atrasado un poco, pero en general estamos en fecha.
It's an amazing place to be.
Thank you so much, Marshall. We have one more speaker to talk a little bit about that
Va
science.
a hablar alguien más, el último.
Just a reminder, after that, we will be taking questions from media on the line. You can press *1 to get into the queue. And for social media, post your questions.
Bueno, hay preguntas, tenemos la posibilidad ya de hacer la pregunta.
Thank you so much. Next we have Jane Rigby from NASA Goddard.
Jane Rigby. Es de NASA Goddard, es científica del proyecto de la parte de operaciones.
The goal here was to build a telescope 100 times more powerful than anything we've had before.
Este es un telescopio 100 veces más potente de todo lo que hemos tenido hasta el momento.
To meet those very demanding science requirements. The engineering images that we saw today are as sharp and as crisp as the images that Hubble can take, but are at a wavelength of light that is totally invisible to Hubble.
Dice, tenemos la misma calidad que tiene el James Webb. Dice, con la diferencia de que podemos captar luces mucho más difusas que el James Webb. 100 veces más difusas.
The point spread function has a full width at half max of 2.3 pixels. That's 70 milliarcseconds. The only way to make those images sharper is to just make a bigger mirror. Now, we took this image to characterize the sharpness, but you can't help but see those thousands of galaxies behind it, right? They're really gorgeous. Webb can't, there's no way that Webb can look for 2,000 seconds.
Adrián pregunta si no se esperaban novedades, que estuviera a punto hasta el verano. No. Todo el telescopio no está a punto. Lo que está a punto ahora es la alineación de los espejos. Ahora lo que viene, creo que es las calibraciones de los equipos, el espectrógrafo, el NIRCam, en fin, todo eso, ¿no? Claro, dice, no tomamos ningún dato científico, todavía seguimos trabajando en la etapa de ajustes.
We now have to align the telescope to all 4 of the science instruments. So every one of those 4 instruments is getting a crisp image. And these 4 science instruments we have to get ready for prime time. We're getting them ready for science. One of those 4 science instruments, MIRI, which eventually is going to be the coldest thing on the observatory at 7 degrees above absolute zero, it's still cooling. So we're cooling that instrument.
Dice, seguimos enfriando los instrumentos y hay uno de ellos que es el más frío de todos. Dice que está a 7 grados por encima, creo que del cero absoluto. Dice, todavía lo seguimos enfriando. Creo que es el MIRI que dijo. En julio, dice, vamos a pasar a la etapa de ciencia.
Of science operations. We have already selected, it's prepared and ready to go, a year of really compelling, demanding science with this telescope. And I'm just so excited to see this science, which was competitively selected, right? We received more than 1,000 proposals.
Hemos recibido más de 1,000 propuestas para hacer la ciencia.
Is going to be studying galaxies that where we're seeing the light as we're seeing these galaxies, they're so far away that we see them as they looked only a couple 100 million years after the Big Bang.
Dice, bueno, vamos a ver galaxias tan lejanas, dice que van a estar apenas unos pocos cientos de años luz después del Big Bang.
How galaxies like our own Milky Way formed. and then evolved over 13.7 billion years of cosmic time. Webb will be studying planets that orbit other stars.
Vamos a poder estudiar, dice, bueno, planetas que orbitan estrellas. En realidad, no está agregando nada a lo que ya sabemos, ¿no? Si no hacemos una pregunta ahora, quedamos por fuera.
Fundamentally, this telescope is going to explore how we got here and what's out there, and what's out there in our gorgeous universe, and that's just starting to come into view now.
Thank you so much, Jane. We're going to move on to the question and answer portion. We're going to open up the mics for the first question, please.
Bueno, viene la primera pregunta. A ver, ¿quién pregunta?
If we don't have our first question, I can pull up a social media question, but let me know.
Nadie ha preguntado, de la prensa.
I'm going to go to a social media question while we work that out. We have a question from Peter on Facebook, who's asking, what about pointing the telescope at different stars? How is it going to rotate? Are there actuators to facilitate this, or does the entire spacecraft move?
You want to take it or should I?
Yeah.
Okay. So the way Webb moves, some people think the telescope moves with respect to the sun shield, but that's not the case. The telescope and the sun shield all move as a single object, so the whole observatory tips and tilts to move across the sky. The way that happens is there's a thing called reaction wheels. These are, in essence, big spinning wheels like a gyroscope within the body of the observatory, and they spin one way to spin the whole telescope the other way.
Sí, es muy posible que...
Telescope track across the sky.
Pero es una muy buena pregunta.
We have a fine guidance sensor. That was the contribution from the Canadian Space Agency that locks on stars and stabilizes the images, moving a mirror that adjusts within the third mirror within, the fourth mirror within the telescope, tips and tilts in response to the signals from the fine guidance sensor to lock onto the different stars. And that's also something we've tested out over the last few weeks, and it's working very well at this point.
Great. Thank you so much. We seem to have worked out the problem with the phone lines, but they should be on now. So we'll take the first question.
And our first question comes from Seth Bornstein from the Associated Press. Your line is now open.
Associated Press está preguntando ahora.
Yes, thank you for doing this. I guess this is for Jane. That first image, can you first tell us what star is this? How far away is it? Has this star been seen with Hubble or any other telescope? And what is the difference between the image you're showing and whatever knowledge we've had in the past?
After the tone, please state your name.
Daniel Regueira, R.
Thank you.
So we sort of plucked this star out of obscurity. It was just minding its own business.
Bueno, acabo de anotarme en la lista para preguntas. Vamos a ver si tengo la oportunidad.
And we picked it because it was convenient for the wavefront folks. It is a nice, boring star of about the right brightness.
It's the right brightness, and it's off by itself with no other bright stars nearby. It's a pretty much generic anonymous star in the sky that worked well for the kind of sensing measurements we needed to do.
¿A qué distancia la Tierra se encuentra en comparación con la Luna? Dice Elencia. Está a 1,5 millones de kilómetros de la Tierra y la Luna está a 1/3. Adrián Braga, muy buena esa pregunta. Sí, me encanta.
Average star in our galaxy.
And then what was known behind that, because this isn't a famous deep field, this is just we've made it a fairly deep field, but it was just a star. So the brightest stars in that image are known in previous surveys, the brightest galaxies. Everything else there is new.
I'll just add again, this star is one of many stars we use throughout the commissioning process of Webb. We've gotten a lot of questions about the stars we're using. They're generally picked out not because they're special stars, but because they're the right brightness and in the right parts of sky for our engineering tests. They're not, intentionally at this point not special stars. They're just, here's a generic star we can use to focus the telescope.
Thank you very much. We will go on to our next question, please.
Our next question is from Chris Jebhart from NASA Space Flight. Your line is now open.
NASA Space Flight va a preguntar ahora.
Yes, thank you so much. Wondering, looking out a little bit ahead to the rest of the mirror alignments, you mentioned that you have to align it to each of the instruments. So I'm wondering, is each
Damián Pelfo dice, ¿qué le voy a preguntar? Bueno, por ahora tengo una de saber qué es lo que van a enfocar, a qué le van a apuntar mientras siguen esperando que los instrumentos se enfríen. Es una buena pregunta, pero me gustaría tener una mejor. O sea que coloquen en el chat.
And seeing very, very close objects in our own solar system. Thank you.
Aaron, question?
Yeah, I can answer that. That's a good question. You know, we initially aligned to NIRCam as an instrument because it has some of those special optics in the filter wheel that Marshall mentioned, just for our alignment process. Now that we've gone through that fine alignment process with NIRCam, we will take a look at the other instruments across the field of view, and we'll balance the alignment of the entire telescope to all 4 of the instruments so that they're all in focus and they're all nice and sharp. But once we're done with that process, then we leave it alone, basically, and we only do maintenance operations is what we call them. So every couple days, we'll take a measurement and see how the alignment looks, see how the wavefront looks, and if it's drifted a little bit, maybe for thermal drift or other reasons, then we can make a tiny correction.
Bueno, dice que lo que está hablando cómo ajustan el NIRCam, por ejemplo, que hacen un ajuste, esperan un par de días, vuelven a chequear, ven cuánto se desvía, luego volver a hacer pequeños microajustes.
Thanks. We are ready for our next question.
Thank you. Our next question comes from Alicia Salter from Mashable. Your line is now open.
Hi, thank you for doing this and congrats. I was hoping just for the general public, could you explain the features of the image? In other words, what's causing those big, bright spike structures and what's giving the image its red color? Thanks.
¿Por qué la imagen se ve en rojo y por qué aparecen esas deformaciones en la imagen, esos reflejos?
The color, that's actually the colors that we used, the engineers used to display it, but ese es el color que se usa de ingeniería para poder verlo, pero en realidad son imágenes que vienen en infrarrojo. La idea es poder ver el contraste en la imagen. But in terms of what the spikes that you see coming out of the star, any telescope that has special structures like the shape of our mirrors will have that kind of spikes in it.
Bueno, y esas puntas que se ven que vienen de la luz es justamente por los reflejos de los espejos.
The things that hold the secondary mirror up, and because of the sort of the way that light travels in, that actually causes something called diffraction that makes those spikes. And you see that most intensely when you have a very
no tienen forma de repararlo. Es una muy buena pregunta, pero no hay forma.
They're dimmer and those effects are harder to see, and that's why you only see it in that very bright star.
Thank you so much, Marshall. We are going to continue with some more media questions. Next one's up.
All right, and our next question is from Bill Harwood from CBS News. Your line is now open.
CBS News va a preguntar.
Thank you very much. I just want to follow up on an earlier question because I'm still a little bit confused about the alignment to date and then what has to be done for the other instruments. So I'm taking it that you're perfectly aligned for NIRCam, and the focus is as sharp as owner said, as sharp as you can get it. But are you moving? I don't understand if it's the secondary that you will move at this point or individual segments to achieve that focus for everybody. I guess I'm just not visualizing how that works, or how the internal mirrors in Webb play into all of that. Thanks.
So the primary things we're doing that are still in front of us, the secondary mirror right now is actually fairly well aligned, and we know that not just because of the star that we just showed you, but the other stars in that field tell us it's pretty well aligned. But we want to make it as good as possible so that it's balanced for all 4 instruments. So we do have to do a little bit of very small tweaks to the secondary mirror alignment. And then also the instruments themselves, several of the instruments have the ability to focus internally to the instrument, and that's something we still need to do, is to get them focused once the telescope itself is fully aligned and fully focused in a way that balances all 4 instruments.
Estamos, para quienes recién se suman, estamos en una conferencia de prensa de la NASA que está compartiendo lo que han hecho hasta ahora y que es lograr el alineamiento de los 18 elementos, de los 18 espejos principales que tiene este telescopio. Ya han hablado cada uno de quienes están en esta conferencia de prensa. Y ahora están en la fase de preguntas y respuestas de la prensa. Estamos acreditados como prensa, pedimos la posibilidad de hacer una pregunta. Vamos a ver si nos toca. Si alguien tiene alguna pregunta específica para hacer, estaría bueno que lo coloquen en el chat, coloquen la palabra pregunta en mayúsculas al primero, así sale destacado y podemos ver.
The big thing that we wanted to achieve, and you've done so. But I'm curious if you anticipate any issues between now and then.
We'll start out with Thomas for that question.
Iván Yarijuama pregunta pregunte cuánto puede afectar las partículas de polvo del espacio, los espejos. Ya han hecho estudios, lo tienen de acuerdo a los impactos que han tenido en otros satélites, en la Estación Espacial Internacional, y saben que inclusive los microimpactos que puedan tener objetos espaciales no afecta el funcionamiento, no va a afectar el funcionamiento del James Webb a lo largo de su vida útil. ¿Qué pasa si sale de la sombra de la Tierra? ¿Se corrige? ¿Hay potencia para ello? Dice Damián. O sea, si se sale, no se va a salir del L2. Y de la sombra la hacen las propias sombrillas del telescopio. O sea que no hay forma. Si se sale y le da el sol, no queda nada. Los datos van a ser públicos, dijeron que sí. Los primeros datos van a ser públicos. Después van a ser públicos, creo que al año de obtenidos, porque primero lo va a estudiar toda la comunidad de ciencia relacionada directamente con el telescopio. Después se abren a todo. No, la ISS no está conectada con
But as Thomas said and others have said, there is work to go. So we're not there on the entire observatory. But just to take that image, that was a 2,100-second image. A lot of things had to work. We had to be able to point. We had to be able to, guide, which means kind of track on that star precisely. It was a fairly long period of time that we took that image. So there's a lot of things that are working really well, but there is more work to go.
All right, thank you. We'll go to the next question from the phone lines.
And our next question comes from Alexandria Witz from Nature Magazine. Your line is now open.
Otra pregunta de la prensa.
My question is for Jane Rigby. Can you just fast forward a little bit more to sort of first science again? We hear dates of June, July. Can you be a little bit more precise on when we'll have more timing on which of those dates, which of those months is accurate? And also, what do we know about kind of the super secret first science observations that are going to be made? Have those targets been chosen? I know you can't tell us what they are, but have those targets been chosen?
Okay, in reverse order. Yes, the targets have been chosen for the super secret first images that will be released.
Andrés pregunta, dice, ¿qué salió mal? ¿Hay algo que quedó como esperaba? No, ya lo han dicho. Todo viene saliendo tal cual como esperaban.
And those targets have been chosen, and those programs have been fully specified. The computer files that tell Webb how to take the data, we have all those in hand. As far as the specifics, we will start science operations when we are done with commissioning. Commissioning is nominally 6 months long. We launched on Christmas Day, so that would be the end of June.
Al final de junio va a terminar el commissioning, o sea, esta etapa de ajustes.
Moving on to the next question, please.
All right, and our next question comes from Passant Ravi from Inverse. Your line is now open.
Thank you. Yes, I'm wondering, with Hubble, we've seen all of these stunning images, but with James Webb, since it's looking at more distant objects, is the aesthetic value or sort of visual value less important, and it's more about the data with these images?
Both and. They're gorgeous.
They're gorgeous. You can't help but enjoy seeing the distant universe.
Pablo Alberto Roldán pregunta si en esa región no necesita corrección de ningún tipo. No, necesita correcciones periódicas para mantenerse orbitando alrededor de L2, donde está ahora. Esa es la limitante del telescopio, en realidad, la cantidad de combustible que tiene para hacer esas correcciones. Que la vida útil se ha estirado en base a que la precisión con que ha sido colocado en la trayectoria el L2 por el Ariane 5 ha sido tan grande que han ahorrado muchísimo combustible que obviamente lo van a utilizar para estirar la vida útil del telescopio.
And that's part of the complexity with calibrating instruments. So I think, just like with Hubble, there are some Hubble images that we take that do have deep aesthetic value and that have scientific value, and it's always a both and.
Yeah, and some of what we're getting from the spectroscopy, we'll be telling you how galaxies are rotating and how the gas in those galaxies is getting blown out of them by supernova. And we'll be determining what the composition of what the gas in galaxies is.
Está hablando de lo que van a poder observar, la rotación de las galaxias, la cantidad, el tipo de gases que salen cuando hay explosiones, por ejemplo de supernovas. Vamos a tener datos como nunca hemos tenido.
Great answer. I'm looking for a lot of giddy and happy as we go forward. All right, we'll take the next question, please.
Our next question comes from George Dvorsky from Gizmodo. Your line is now open.
Edison Suárez dice, ¿se podrían hacer ajustes o reparos directamente al telescopio con caminatas espaciales? No, no hay posibilidad. Constelación dice que Webb es increíble que vio galaxias de fondo en la imagen de la estrella. A mí me parecían galaxias. Sí.
The unveiling of the telescope. And I know that Thomas already said that nothing's going to keep him up at night anymore, but I'm wondering if the rest of the team agrees with that. Are there any steps that are really still kind of harrowing or problematic to disrupt the process? Thanks, guys.
Preguntaron si hay algunos pasos que puedan llegar a cambiar lo que esperan que suceda ahora en los próximos meses.
If the secondary mirror hadn't deployed, we call it secondary not because it's not important, but because it's the second after the primary, right? If the secondary hadn't come out, all that beautiful light coming into the primary was just going to bounce off into space forever, and we wouldn't detect it. So there were parts on this mission where it's like, well, this is going to work or we're done. We're past those points now. That's what Thomas was getting at, and we're now to the stage where if things don't work, we're looking at we're looking at partial degradation of the total science return. We have 4 science instruments. All 4 of them have turned on and said, hi, our aliveness check says we're okay. For some of those, for 3 of
Rosa Sierra dice, las explosiones solares son rechazadas por el telescopio, ¿es suficiente la cobertura que llevó?
MIRI has to cool from, it's in the temperatures in the 90s right now, 90 Kelvin, 90-something Kelvin, it needs to get down to 7 Kelvin. So that's something that I'm looking at, right? This has this closed circuit refrigerator that recirculates helium to chill MIRI much colder than the rest of the science instruments. So that's something where, okay, that's a big deal. We want to get MIRI cold. But we're now looking at where, yes, space is a dangerous environment, and Webb is up there in space, and every day we have to keep it safe, and there's work to do that. But most of what we're looking at going forward is if things don't work, we're looking at gradual degradation of the total return rather than shows over folks.
And a key thing about the telescope is the telescope feeds all 4 instruments. So when the telescope doesn't work, then that really affects the entire mission. And we're now beyond that point. Now, there's always the potential that some subsystem might, not work at some point.
Bueno, está hablando, dice que lo principal es que toda la parte de espejos y captura de luz y todo está funcionando tal cual como esperaban. Dice. Hay todavía alguna posibilidad de que alguno de los instrumentos que lleva no funcionen tal cual como se esperaban, pero dice la parte principal de esto es que la captura de luz, lo rebote en el secundario y llegue y pasen a través de los prismas, ya está hecho, o sea, está funcionando. Vamos a ver cómo siguen en la etapa de comisión, ¿no? O sea, de puesta en servicio.
How big is the group? Who is involved and from which institutions? And when exactly was the list of targets finalized? Thank you.
Get back to them. What I am hearing in the room is that we will get back to you on that, Marina. I don't know that we have the exact size and people at our fingertips, but I will follow up with you when this is over. You can drop me an email and I will get you what I can on that. Do you have another second question, given that we couldn't answer your first?
I do. Thank you.
Go for it.
Can you tell us, so we've heard a bit about the star at the center of this image. Can you tell us more about the galaxies that are in the background? You know,
Acaban de preguntar sobre las galaxias que hay
they are,
atrás.
and how does this compare to how Webb will see galaxies in the future? You know?
¿Y cómo vamos a ver las galaxias en el futuro?
All right, well, I guess I'm the galaxy geek in this crowd. Okay, so as we said, this wasn't a famous deep field. This isn't a place where we studied, where we've known what's out there. Just eyeballing it, I mean, we got those data, they came down Saturday night, so I was eyeballing them Sunday morning in my pajamas.
Dice, recién tuvimos estos datos el sábado de noche. Dice, los llegué a ver el domingo y se estaba todavía de pijamas.
Away, but would actually have to take some spectroscopy to get you a better answer than that. We can do spectroscopy once we get the science instruments ready to go.
Dice, habría que hacer espectrografía para poder ver un poco más de eso, pero dice, vamos a poder hacerlo cuando tengamos los instrumentos, el resto de los instrumentos funcionando.
Has this really cool micro shutter array where it has 250,000 little doors that can open and close, and so it can take spectra of dozens of targets within that field. And so one of the key science capabilities that this telescope has is to target a field like that and pick the most interesting 30, 40 galaxies and say, I want a spectrum of that. And with that, you know exactly how far away each of those galaxies are, and depending how you do it, you understand how much heavy elements, carbon, oxygen, nitrogen, those galaxies have relative to hydrogen. So that tells you how many times the gas.
Está diciendo la forma en que una vez que tengan los instrumentos funcionando es cómo capturan los datos de cada una de las galaxias que ven ahí en la foto.
We picked this field just for the wavefront sensing calibration. It was not chosen for these galaxies.
Dice, elegimos esto, dice, por lo que se ve justamente, porque es una estrella que está aislada, no por las galaxias que pueda ver.
So, you know, scientists out there, they're grad students at some university, can download these data in June and start answering these questions from this and all the other data that's taken during this commissioning process.
Recién vamos a poder tener respuestas sobre eso en junio, dice, cuando estemos sobre el final del proceso de calibración.
Images around the fine phasing target in multiple wavelengths. We're just going to let that data out to the scientific community along with those other observations.
Dice, y bueno, y vamos a tener esos datos y se los vamos a compartir con toda la comunidad cuando.
Now we'll take two. The first one is Torrin T on Instagram asks, what is the precision between the mirror segments now that they are aligned when it comes to the alignment?
¿Cuál es la precisión de los espejos ahora que están alineados?
Presentation. So our actuators have a resolution. We can move and maintain a motor position to about 9 to 10 nanometers. So that's
de 2 a 9 nanómetros
es
la posición.
And our sensing budget means that we aren't actually within 10 nanometers segment to segment.
Nuestros requerimientos son 10 nanómetros.
We're below 100 nanometers easily.
Yeah, we're absolutely.
And that's over the whole telescope and the instruments.
Full system. Yeah. Over the full system. Yeah. So each individual segment to the other segment is well under 100 nanometers.
Y en relación uno a otros, dice, están muy por debajo de los 100 nanómetros.
Is from Briannian Motion on Twitter, who asks, what, if any, are the lessons learned from Webb so far that we can take into the next space telescope?
¿Qué es lo que han aprendido hasta ahora? Dice, para que podamos poner en el próximo telescopio que se mande.
You know, one thing about Webb, I mean, obviously it's a super cold telescope, and that really drove a lot of the design. Of course, that huge sun shield was needed to cool things down.
Una de las cosas que tiene el Webb es lo frío que está.
Telescope, and what that means is that unlike, for example, the Keck telescope, which is a ground telescope in Hawaii where they actively move mirrors, the Webb mirrors are designed to always just kind of be where they are, and then only every few days do we update them. And that made a lot of sense for a really cold telescope, but it also made it difficult to prove the telescope was going to work and to design everything from the mirrors to the structure that holds it. And so one of the things that we think in the future for these large segmented telescopes is we will make use of the types of things the ground telescopes have, which are active controls. And that would make our ability to test it easier, and it would make us also be able to make an even finer telescope, which some of the future observatories may want to do. For example, if you want to study exoplanets particularly Earth-like planets around stars, which is one of the future missions that
Bueno, dice que el proceso de
recommended by the National Academy
alineamiento es una de las
Committee.
cosas que van a
We're
tener
gonna
que
need a very
simplificar
precise nerve
para
service that's extremely
el próximo
stable.
telescopio.
And so we were going to probably want to migrate from this sort of approach we took for this very cold telescope to a more active telescope.
Dice, bueno, vamos a tener que migrar de la idea de con la que se manejó este telescopio, a ver, y hacerlo más como se hace. Es hacerlo más como funcionan los telescopios en la Tierra, que se pueden mover los espejos. Bueno, se escucha horrible esto. No se entiende nada. El audio está desfasado con respecto a la imagen, es correcto, Gabriel. Estamos conectados vía telefónica con NASA porque tenemos la posibilidad de hacer preguntas y el video ahora que estamos viendo es a través de internet y viene desfasado, sí, totalmente.
Great, thank you.
So the cooling process.
Para la gente que recién se conecta, estamos en una conferencia de prensa de la NASA liderada por Thomas Zurbuchen, administrador asociado de NASA, que están compartiendo qué es lo que ha sucedido hasta ahora, que han conseguido alinear los 18 espejos del James Webb. Y obviamente ya hablaron todos, ahora está en la última fase de preguntas y respuestas, con la prensa y con las redes sociales. Estamos acreditados como prensa, por eso el audio está desfasado, estamos conectados vía telefónica con NASA y el audio del video está silenciado, por eso están desfasados.
This is not just a refrigerator that you turn on, but has its own, I think it's a 6-step process. And I believe they're right now on the third stage of that cool down process. The fourth stage will begin about a week from now. And that's really going to accelerate the cooling of MIRI.
And did we really address what's happening with science commissioning next with commissioning instruments? Do you want to mention just what our next steps are? Yeah, it was just what's happening next for commissioning of the science instruments.
We covered some of that. Let's see. So science instruments, MIRI has to get cold. That is the really big one. We're walking through for each instrument, there's a set of activities that each one has to show that it is working. And it's things like stepping through the filter wheel and making sure that you get every position in the filter wheel that you want. Getting the darks, because to understand the properties of the detector so that we can take that out, so that we're seeing the sky and not what the detectors are doing. So there's so we're doing every step in that to get those instruments ready for science.
Thank you. We are taking 2 more media questions. We'll take the next one, please.
Our next question comes from Irene Klotz from Aviation Week. Your line is now open.
Dos últimas preguntas.
Thanks very much.
No nos tocó esta. Vamos a ver si estamos en la última,
one
¿no?
question for Jane and then for Thomas. Are you seeing any impacts in the JWST science community over the situation in Ukraine? Are there any Russian
¿Hay impactos en la comunidad científica por el tema de la guerra en Ucrania?
first-year science? And for Thomas, can you address that same question more generally to the NASA science program? Thanks.
So thank you, Irene. Unfortunately, I'm going to have to circle up with you afterwards. We're going to try and stick to some of the science and the alignment right now, but I will get you any information and updated statements we have. So I'll circle up with you as soon as we're done here. If you have another question, I would take it. Otherwise, we can go to the next one.
Oh, can Thomas not address that question either?
Yeah, we'll stick to responding offline.
Thank you. And our next question comes from Daniel Guerra from R-Drone-UI. Your line is now open.
Hi, how you doing? And thank you for this. Congratulations to all. I think this question could be for Thomas. And given the little lifetime of this beautiful telescope, NASA could be doing some plans to refuel the telescope to get more lifetime on this?
So you're right that every time we build a telescope, we think about how long we can operate it. I want to tell you that the delivery by Arianespace and the European Space Agency was just fabulous. Frankly, the lifetime of the telescope that we initially said at, about a decade or so is, we believe, exceeded based on what we see there. As we're kind of learning how to operate and point in the sky, the estimates of the lifetime will really become more accurate. So as we come to the end of commissioning, I'm sure we'll give a much more accurate update. I don't know, Lee, whether there's anything you can say already now that you haven't already said. You were the person who talked about lifetime before, but that's what's on our mind.
Yeah, I think Mike mentioned during one of the press events that he thought it would be 20 years. And the one thing I can add is that on the actuators, they will last as long as the rest of the observatory. They're working exactly the way we expected. They have a very long lifetime, so there's no changes to anything in the sense of the lifetime of the system. And I don't think there's any new updates, but as Thomas mentioned, as we go through commissioning, there might be some other additional updates from the systems team.
Okay, if there is opportunity to make a new question.
I think we do have time, yes. Go right ahead.
Okay, what will be the next target of when science starts inside the solar system?
Inside the solar system. There is an early release science program to study either Jupiter or Saturn, to study the gas giants in our own solar system, and in particular their moons. So there is a program to do that has been competitively selected and is in the queue. We are doing some commissioning activities to go double check that we can look at a target as bright as a planet in our own solar system and still be able to point at and get data on the nearby orbiting moons.
Thank you all. Thank you.
There are also some approved programs to do Trojan asteroids, and there's an approved program to study those asteroids that are interstellar visitors from our solar system, from other asteroids that have come in from outside our solar system.
Right, Jane. And of
that's
course,
amazing.
The reason these are such a high priority and they did so well in the reviews is of course, as we have other missions actually exploring the solar system, the information that we can get from this amazing telescope will really help us run these missions better. Lucy is on its way to the very bodies that you just talked about, and yesterday I met with the Clipper team that, of course, is going to launch in 24, that amazing mission to go to Europa, which is one of those moons that you just talked about.
Thank you. Thank you.
Thank you so much to everybody who has watched today, who was on the line asking questions, and who has talked to us today. We are going to finish up now. You can follow along.
Bueno, ahora vamos a hablar un poquito sobre las preguntas.
And what's coming up this summer and all of the incredible science that we have talked about here today on nasa.gov/web. That's WEBB. You can also follow along in the social media conversation using #UnfoldTheUniverse. And of course, NASA.gov is going to tell you all about the ways that Webb interacts with all these other incredible science missions and all that we're doing in the solar system and beyond. Thank you so much for being here today. Goodbye.
Bueno, cortamos la comunicación. Volvemos ahora sí al video. Vamos a poner a ver si volvemos a escuchar nuestra pregunta. Quiero darle las gracias a la cantidad de gente que preguntó en el chat y de las cuales tomamos gran parte de las cosas.
The telescope moves with respect to the sun shield, but that's not the case. The telescope and the sun shield all move as a single object. So the whole observatory.
An important.
Just for the general public, could you explain the features of the image?
I can use Fred light, but in terms, so we have these 6 sides, and those effects are harder to see, and that's why you only see it in that very bright star.
Thank you so much, Marshall. We are going to continue. We'll stick to responding offline.
Thanks.
So thank you, Irene. Unfortunately, I'm going to have to circle up with you afterwards. We're going to try and stick to some of the science and the alignment right now, but I will get you any information and updated statements we have. So I'll circle up with you as soon as we're done here. If you have another question, I would take it. Otherwise, we can go to the next one.
Oh, can Thomas not address that question either?
Yeah, we'll stick to responding offline.
Thank you. And our next question comes from Daniel Riguera from R.
Daniel Riguera, soy yo.
UI. Your line is now open.
Hi, how you doing? Thank you for this. Congratulations to all. I think this question could be for Thomas. And given the little lifetime of this...
Bueno, lo felicité a todos y dije, creo que esta pregunta es para Thomas Urbuchen, que es el administrador asociado de la NASA.
Beautiful telescope.
Él puse, dada la poca vida útil que tiene este increíble telescopio,
NASA could be doing some plans to refuse.
NASA tendrá algunos planes, dice, en el futuro, dice, para poder hacer una recarga de combustible, un refuel.
The telescope to get more lifetime on this.
Para darle más vida.
So you're right that every time we build a telescope, we think about how long we can operate it. I want to tell you that the delivery.
Dice, cada vez que hacemos un telescopio, evidentemente, una de las cosas que calculamos es el tiempo de la vida útil que tiene. Y ahora es cuando habla de lo bien que hizo el trabajo Ariane Space con su cohete Ariane 5, que justamente le produjo un ahorro importante del combustible para su inserción en el punto L2, donde está hoy colocado el telescopio, y ese combustible ahorrado le va a permitir tener una mayor vida útil.
By Arianespace and the European Space Agency was just fabulous. Frankly, the lifetime of the telescope that we initially said at, about a decade or so is, we believe, exceeded based on what we see there. As we're kind of learning how to operate and point in the sky, the estimates of the lifetime will really become more accurate. So as we come to the end...
Bueno, dice, primero estaba planificado para unos 10 años, dice, y a medida que estamos trabajando en este telescopio, estamos aprendiendo más, dice, eso nos va a permitir calcular cuánto va a ser la vida útil del telescopio.
End of commissioning, I'm sure we'll give a much more accurate update. I don't know, Lee, whether there's anything you can say already now that you haven't already said. You were the person who talked about lifetime before, but that's what's on our mind.
Yeah.
Bueno, le pasa la palabra a otro de los que está en la conferencia esta de prensa, y Ali Finberg, que es el administrador del elemento óptico del James Webb, y le dice, ¿tenés alguna otra opinión también al respecto?
I think Mike mentioned during one of the press events that he thought it would be 20 years, and the one thing I can add is...
Creo que hemos hablado, dice, ya en otras oportunidades con la prensa, en cual la vida podría llegar a ser extendida quizás a unos 20 años.
Is that on the actuators, they will last as long as the rest of the observatory. They're working exactly the way we expected. They have a very long lifetime, so there's no changes to anything in the sense of the lifetime of the system. And I don't think there's any new updates, but as Thomas mentioned, as we go through commissioning, there might be some other additional updates from the systems team.
Bueno, dice, yo creo, dice que la duración del telescopio también va a estar dada por el resto de los componentes. No hay nada que nos haga indicar que esto haya cambiado, dice, pero estoy seguro que vamos a poder hacer alguna actualización un poco más adelante, ¿no?
Okay, is there an opportunity to make a new question?
Hay oportunidad de hacer una pregunta nueva, se la tiré ahí de una.
I think we do have time.
Sí,
yes.
tenemos.
Go right ahead.
Okay, what will be the next target of when science starts inside the solar system?
¿Cuál va a ser el primer blanco? O sea, ¿qué le van a apuntar con el telescopio cuando comiencen las operaciones de ciencia dentro del sistema solar?
Inside the solar system. There is an early release science program.
Hay un programa del inicio de ciencia del James Webb
To study either Jupiter or Saturn,
para estudiar Júpiter o Saturno,
gas giants in our own solar system, and in particular their moons.
y particularmente sus lunas.
So there is a program to do that has been competitively selected.
Hay un programa para hacer eso que ha sido seleccionado competitivamente.
In the queue. We are doing some commissioning activities to go double check that we
Estamos haciendo actividades de ajustes, de commissioning, para hacer un doble chequeo.
can look at a target as bright as a planet in our own solar system.
Entonces queremos enfocarle algún programa, algún planeta en el sistema solar.
And still be able to point at and get data on the nearby orbiting moons.
Entonces queremos ver para obtener datos de alguna luna que lo esté orbitando.
There are also some approved programs to do
Hay también programas aprobados para hacer
Trojan asteroids,
para enfocarle a asteroides.
and there's an approved program to study those asteroids that are interstellar visitors from our.
Y también hay un programa para apuntarle a asteroides o a objetos interestelares, visitantes interestelares, como habíamos preguntado sobre el Oumuamua en la conferencia anterior.
Solar system from other, asteroids that have come in from outside our solar system.
Right, Jane, and of course the reason these are such a high priority and they did so well in the reviews is of course
Y estos temas son de muy alta prioridad.
as we have other missions actually exploring the solar system. The
Y hay otras misiones, por supuesto, para explorar el sistema solar.
information that we can get from this amazing telescope will really help us run these missions better. Lucy is on its way.
Dice, y hay otras cosas junto con esto. Está Lucy, por ejemplo, que está en camino, ¿no?
To the very bodies that you just talked about, and yesterday I met with the Clipper team that
Ayer me encontré con el equipo de Clipper,
of course is going to launch in 24. That
que se va a lanzar en el 2024.
amazing mission to go to Europa, which is one of those moons that
Es una increíble misión que estamos haciendo Europa.
Thank you so much to everybody who has watched today,
Bueno.
who was on the line asking questions, and who has talked to us today. We are going to finish up now.
Bueno, creo que esta es una de las cosas más increíbles que nos pasan. Gracias al apoyo que estamos teniendo de todos ustedes, a nuestro registro como prensa, a la NASA, los distintos sitios de NASA, porque no solo hay un sitio específico, sino que inclusive cada lugar de lanzamiento maneja las comunicaciones con la prensa, nos permiten acceder a esto, a preguntarle directamente a la gente que está involucrada en los programas, a obtener respuestas. La verdad, me siento increíblemente honrado, orgulloso de poder hacer estas preguntas y compartirla con ustedes, con la gente que le interesa la ciencia, el espacio, todo lo que sucede así, en español. Voy a leer un poquito de los mensajes que hay. Ya saben, cuando hay una conferencia de estas, creo que lo importante, los voy leyendo también los mensajes, pero no contesto todo porque quiero estar participando de la conferencia de prensa, tal cual como estamos acreditados y me parece también un desaire no estar escuchando lo que dicen y el resto de las preguntas, que aparte hubo preguntas muy interesantes, que vamos a seguramente a hacer algún video sobre esto o vamos a ponerlo en las redes sociales tal cual como lo hacemos siempre. Voy a estar ahora, en cuanto cortemos este streaming, un poquito en Discord. Si quieren los que están acá, los invito que vayan al servidor de Discord, que entren en el canal de chat de voz, que voy a estar ya abriendo nuestro Discord y voy a sumarme allí. Rodrigo Pérez dice, excelente Dani, muchas gracias, sos un capo, qué canal. Muchísimas gracias. No, esto es por el gran apoyo que tenemos de ustedes. Esto es porque están suscriptos, porque comparten en todas las redes lo que estamos haciendo, nos ayudan a aumentar la cantidad de gente y nuestros seguidores. Todo esto nos da la posibilidad de eso y nos va a seguir abriendo puertas para mucho más todavía, para muchísimas cosas más. Sinceramente, no tengo palabras para agradecerles a ustedes esto. Alfredo Bonet dice, la vida útil depende del número de cambios de enfoque, giros, calibrados, etc. Por lo tanto, será una función del volumen de cambios de programas de observación. Correcto, correctísimo, Alfredo. Lo increíble es que tú puedas hacer un programa así y con un nivel enorme, dice Adrián Braga. Muchas gracias. David Medina dice, muy buena Daniel, saludos. De aquí a 20 años será obsoleto. Bueno, y ya se vio todo. Bueno, podría llegar a ser que sea obsoleto. Yo creo que dependiendo un poco de eso es que van a definir o no si mandan. Porque no se olviden que una misión de mandar una nave al punto L2 con combustible para poder cargar el web, creo que el web no debe tener la posibilidad de recibir combustible externo. Ese es el gran problema. Hay que ver dónde están los tanques, cómo se llenó, a ver si hay posibilidad de hacer un acople rápido y poder trasvasar combustible. No creo que sea una cosa sencilla, porque eso se debe haber hecho cuando el telescopio ya estaba puesto en el tope del cohete, pero en fin, puede ser una muy buena posibilidad. Muchas gracias por toda la información que nos brindas, Daniel, dice Nico Beas, eres un crack. Un breve resumen, Daniel, recién entré al directo. El resumen es, en pocas palabras, el telescopio James Webb ha sido alineado, los 18 elementos han sido alineados con una precisión entre 2 y 9 nanómetros. Nanómetros es, si uno habla de metros, es 0, metros, le agrega 9 ceros y después pone el número 2 o el número 4. Esa es la precisión de movimiento que han tenido que hacerle en los espejos para poder alinear unos con otros y lograr de que esa primera imagen que ha logrado el James Webb, que en realidad es una imagen de calibración, nada más, no es, a ver si la consigo colocar. Aquí está, ahí la tengo. Esta es la primera imagen del telescopio James Webb. En realidad se ven, esto que se ve acá aparentemente sí, son galaxias. Preguntaron si se podía llegar a obtener algo más del resto de las galaxias. Y en realidad dicen que en esta fase eso no solo no les importa, sino que no pueden hacerlo porque el resto de los instrumentos, o sea, los instrumentos del James Webb recién ahora están en la fase de enfriamiento y no tienen forma de obtener los datos de esas galaxias. Que eso va a ser en la próxima etapa, ¿no? Fines de junio, en realidad, todo lo que podamos ver del telescopio James Webb, que dicen que vean en las redes, mejores imágenes o lo que sea del James Webb, no es cierto, no va a ser cierto hasta julio. Ya lo dijeron, los primeros datos científicos del telescopio van a ser en julio. Esta primera imagen es una imagen de calibración a una estrella que está aislada, que no hay otras estrellas, y fue elegida por el brillo que tiene, que les permite hacer la calibración de esos 18 espejos y lograr sumarlos como si fuera uno solo. Bueno, eso obsoleto lo pongo en dudas, dice Diane Braga, porque el Hubble, según las informaciones, estaba para descartar, pero hasta el momento sigue sorprendiéndonos. Justamente. Yo creo que lo de obsoleto en realidad podría llegar a ser porque fallen los equipos principales, porque los espejos se deterioren de una manera que no puedan reflejar la cantidad de luz necesaria, porque se tranquen algunos de los motores, en fin, hay muchísima cosa que puede llegar a fallar, a pesar de que eso está construido de una forma que si uno dice está pensado para que dure 10 años, seguramente va a durar 20 o 30 años, como vemos que sucede con la mayoría de los equipos espaciales que se mandan, o sondas que se han mandado a otros lados y todavía siguen funcionando, como por ejemplo el Ingenuity, ese helicóptero que está volando en Marte, que ya superó todas las expectativas y que la NASA ahora está estudiando de extender la misión del helicóptero Ingenuity. Lo mismo va a suceder seguramente con el telescopio. Si ven que sigue continuando dando nuevas imágenes, no lo van a pagar. Se necesita sí igual mucho dinero que tienen que darle, porque no es solo decir no apago el telescopio, sino que hay muchísima gente que está involucrada para poder mantenerlo en vuelo, para poder mantenerlo enfocado, para seguir haciendo las misiones de ciencia, para recibir los datos, en fin, para un montón de cosas. Eso solo es una gran inversión de dinero. Entonces, a eso se refieren cuando la NASA dice vamos a darle más vida al helicóptero, por ejemplo. Lo que están haciendo es dándole un nuevo empuje de dinero a todos los equipos que están trabajando en esa fase del programa. Bueno, no voy a ir, estaba yendo para atrás y hay tantos mensajes que es imposible leerlos y es imposible poder contestarlos todos, ¿no? Felicitaciones, Daniel, menos mal que no vino a la inspección del agua, dice Damián Pelufo. Vino ayer, no, 2 veces, no, ya está, ya inspeccionaron, ya se fueron, quedó todo pronto, ahora hay que tapar el pozo donde reparamos el caño y está todo bien. No. Bueno, con esto terminamos, nos vemos, recuerden, mañana el rollout, o sea, la llevada del cohete SLS al sitio de lanzamiento, van a hacer un ensayo con combustible, en inglés eso se llama wet rehearsal. Lo que hacen es cargarlo de combustible, hacer un conteo de lanzamiento, o sea, van a estar toda la gente que esté involucrada el día del lanzamiento trabajando como si hubiera un lanzamiento real. Van a hacer un llamado de scrub o cancelación a T-10 minutos y de ahí todos los datos que obtengan van a ser usados para corregir los defectos que tengan para que el día del lanzamiento efectivamente haya un lanzamiento. Contestarle a Antonio, decirle que sí, dice Adrián Braga. A ver, Master, mañana tenemos transporte del SLS, es lo que estaba hablando. Sí. Lo tenemos programado a una hora, creo, no sé exactamente ahora la hora, porque lo hicimos muy de apuro. Los que siguen conectados, si dejan el video corriendo hasta el final, tiene que aparecer ese video, así le activan el recordatorio y mañana reciben la notificación de YouTube para unirse a esa transmisión. Les agradezco enormemente a todos. Vamos a poner nuestra pantalla final. Vamos a poner los títulos. A ver si los tenemos ahí a mano. Si están a mano. Esto es como manejar una nave espacial, ¿no? Hacerlo uno solo. Pero a ver si aparecen ahora ahí los títulos. Sí, aparecieron. Impecable. Increíble imagen esta de la Tierra desde la Estación Espacial Internacional que nos dejó la NASA al finalizar la transmisión. Rosa Sierra nos saluda también. Excelente la entrevista, muy interesante. Gracias a ti por lo que haces. Gracias, luego lo veré con calma, dice Germán Ramos. Bueno, nos vemos entonces mañana. Un abrazo enorme. Gracias. No me canso de decirlo. Chao, chao.